Hi, this is Dr. Eddie Morgan at Clovis East High School, getting ready to help you with your homework. We're looking at Math 1, Worksheet 2.4a. Once again, each of the problems here is similar to the problem on your homework. If you need help on a particular problem, fast forward to that problem, watch the video, and you should be able to do your homework. Let's get started. Problem 1 says that Lindsay is filling her pool to get ready for the summer. She's using her hose to fill it at a rate of 14 gallons per minute. So we're looking for one that has a constant rate. Notice this one goes up at first and then levels off like she stopped and then goes on. And it doesn't mention anything about her stopping, so we can eliminate that one. Notice number C doesn't even start at 0. You'd figure she's putting pool in and it's going to be going up at some rate. But this one's going down there, so that's eliminated. Here, we start at 0, and notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 14. So this is the one we're looking at. And so graph A would be the best graph for that scenario. Problem 2, Isaiah is training to participate in competitive trampoline. In his best jump, he can reach a maximum height of about 9 meters. That's his best height. And he spends about 2 seconds in the air. So think about trampoline. He's going up. So we've got a situation in which he's going to go up, he's going to stay there a little bit, and then he's going to come down. So as you look at these, graph A shows him going up, but not staying at all and not coming down. Graph B actually has him starting and going down and coming up in a straight fashion. And so what we have that fits better is here, up and then down. And so the answer there would be C. Problem 3, it says that Jasmine starts each day to walk to school at about 7:45. And then 5 minutes later at 7:50, she stops at her friend Victoria's house. And she usually waits around here for another 5 minutes while her friends get ready. And then at 7:55, they start off again. So if you imagine we're starting at 0, we're going to walk to our friend's house, we're going to stay a while, and then we're going to take off. So you can see graph B looks like the better graph solution here. Here, we start someplace else and go someplace. This is kind of a round one again. So our answer is going to be B. Problem 4 says that Jasmine is saving for college. She has invested $500 in a mutual fund, and she's going to earn an average of 7% annually. That means if I'm graphing this, that she has a place where she starts at 500, and then she's earning interest annually, and the interest is going to go up. And so we're looking for something of that nature, which is B. Notice here, this one starts and goes backwards. That's completely wrong. Here, this looks like that equation we just did where it goes up, it stays the same. But in our case, the key is we start at an amount, and then we go up from there. Problem 5 is not a well-written problem. It says that Marcus is at the top of an observation tower, and he drops an action figure with a parachute and watches it descend. So if I were looking at this, thinking that with a parachute it's going to drop slowly, I would say he's up here and it's going to drop slowly to the ground. If you look at our examples, none of them actually fit that one. A is out because A has it goes up. B shows it going up first and then going down. So the most logical one has to be here where it goes down, even though it's going down pretty fast, and it doesn't represent any time here. If I were actually, this one could be, I would say B is possible if you added that he tossed it up first and then it dropped. You could see where B might be the answer, but given what we have, we're going to have to go with C as the only logical one because it doesn't tell us that he topped it off. Problem 6 says that Janelle holds a raffle to raise money for a children's hospital. Participants who enter the raffle guess the number of peanuts in the jars. She records the number of peanuts. She records the number of peanuts each participant guesses and the number that they're off by. Now, if you're thinking about this, since she's doing the off by on this side, some point out here is the exact number of peanuts, and that's where if you got that number, you would also be off by 0. And then, but if you're here, you're going to be off by 1. If you're here, you're going to be off by 2. And so you see your graph is going to look something like this, an absolute value function. And so our answer here is going to be A. Problem 7 says that Madison enjoys bicycling for exercise. Each Saturday she bikes a course she has mapped out around her town. She averages a speed of 12 miles per hour on her journey. Now notice that we're graphing distance. So I'm assuming that what I'm graphing here is the distance, and that's going to be in miles. And the other time she goes miles per hour, so I would say I would be graphing time, and that's going to be in terms of hours. So as time goes by, she goes a certain every hour she goes 12 miles, and so we have a steady graph of this nature. Problem 8 says that Natasha is filling the bathtub with water in order to give her dog Buster a bath. The faucet fills the tub at an average rate of 12 gallons per minute. These are actually going to be our two variables, gallons per minute. And obviously at that rate, the number of gallons is going to depend upon how many minutes I'm filling it. And so the independent is going to be the time, which is going to be in minutes, and how much water is gained, the amount of water, and that's going to be in gallons. So notice the amount of water in the tub goes up as the time goes by. In problem 9, Marcus throws a football straight up into the air. After it reaches a maximum height of 20 feet, it descends back to the ground. Now notice if we were just measuring height, then it would simply go straight up and go straight down. But this is height over time, as time goes. So in other words, we're looking at time, probably in seconds. And then this is our height here in feet. And so over time, as time goes this way, it goes up and then eventually comes on back down. In problem 3, Chloe is using a pump this time to drain her backyard pool. So it's already got water in it. The pump removes the water at an average rate of 15 gallons per minute. Again, gallons per minute give us our two variables, the amount of water and how much it's going down. Well, it goes down per minute, so time in minutes is our independent. As time goes by, the water descends. And so here's our amount of water in gallons. Notice that it starts at some place and then goes down at a steady rate. Problem 11, Jermaine is saving money to purchase a car. He puts $850 in a savings account that earns 1.65% interest. So in this sense, he starts at this amount of money, $850, and then it goes up. Now obviously here is the amount of money. This would be our dollars amount earned. In dollars, and this is going to be our time here, and it could be in years. It says annually, so each year he earns that amount, and so we see it starting at each earning and going up. All right. I might say here I would actually have named this not interest earned, because interest earned would have actually started at 0. Here is the amount saved, because he starts with $850 and then it goes up. Problem 12 says that Zachary enjoys hiking. On the first day of his latest hiking trip, he hikes through flat terrain for about 8 miles. On the second day, he hikes very steep terrain for 3 miles, and then he hikes through some hilly terrain for about 6 miles. The point of this is on the flat terrain, he can go fast. And so you notice here, it goes as steeper because he's going faster. The next day on very steep terrain, he has to go slower, and he also doesn't gain as many miles. So notice on the first day, he makes it 8 miles, but the next day he only gets up to 11, meaning he made it up to 3 miles. And then he has hilly, which is kind of in between. Once again, you know, he can go a little faster than he did the day before, but not as much. So in this case, what's being measured over here is distance, which is in miles. And over here, you could say this is time. Probably not in days, although you could say it in days.